This is a metal coin. Hold that. Sort of.
Metal coin.
A metal disc.
Metal disc.
Right? Somewhat dense. This is, as you will see, is a little snipped out piece of a feather.
Yeah.
Now, if I were to ask you to hold those out in front of you and let them go at the same time, what would your, first of all, what would your prediction be about how they would fall?
That this one would fall faster.
All right, give it a shot and see what happens. Yep.
Yes.
Right?
I should have said that the coin will fall faster.
Yes,
yeah.
that the coin will fall faster. And it hit the ground. It made a sound as the feather was fluttering down. Mm-hmm. We know that it's gravity that accounts for why either of them goes down when you let go of them. Mm-hmm. Right? So somehow this is a gravitational effect. Aristotle famously, on the basis, presumably, of this kind of observation, said, yeah, heavier things fall faster. Which wouldn't surprise you, because you lift a heavier thing, you'd say, hey, you know, it's heavier. There's a force, there's a stronger force on it going down. Heavier things should fall faster than lighter things. Now, Galileo, because of course he really had to undermine a lot of Newtonian physics to do what he was doing, said this is all a mistake. Now, he had interesting kind of a priori arguments about why it just is impossible. It's kind of internally self-contradictory to say that heavier items fall faster than lighter items. We could go through if you want to. But here's the passage from the Two New Sciences where he talks about this. Salviati, I seriously doubt that, so if you'll remember, those of you who don't know, the Two New Sciences is Galileo's discussion of two new sciences. It's like his other famous book is on the two chief world systems, which was about arguing for Copernicus against Ptolemy. And you have the same characters. Simplicio represents an Aristotelian, a kind of scholastic Aristotelian who doesn't do any experiments and gets all of his physics and all of his natural science by reading Aristotle. And Salviati is supposed to be the neutral observer in the debate, and Sagredo stands in for Galileo. So Salviati, I seriously doubt that Aristotle ever tested whether it is true that two stones, one 10 times as heavy as the other, both released at the same instant, to fall from a height of, say, 100 brachia, differed so much in their speeds that upon the arrival of the larger stone upon the ground, the other would be found to have descended no more than 10 brachia. So you see, the idea is that he's reading Aristotle as saying the 10 times heavier stone will fall 10 times faster. So when the heavier one hits the ground at 100 brachia, the other one will have only fallen 10. Simplicio. But it seemed from his words, Aristotle, that he appears to have tested this, for he says, quote, we see the heavier. Now this we see suggests that he had made the experiment. A very careful reading of Aristotle. Sagredo. But I, Simplicio, who have made the test, assure you that a cannonball that weighs 100 pounds or 200 or even more does not anticipate by even one span the arrival on the ground of a musket ball not more than half an ounce, both coming from a height of 200 brachia. So these are fictional characters, but the claim is Sagredo did this experiment. People may have heard of this as Galileo dropping a heavy light object off the Leaning Tower of Pisa. There's all kinds of historical debate whether he actually dropped them off the Leaning Tower of Pisa and whether there was anybody to watch and so on. Apparently that's not settled. But there's a pretty clear direct implication here that Galileo did take a relatively heavy cannonball and a light musket ball, drop them, and notice they didn't hit exactly together, but they hit much more closely together than Aristotle's theory would allow. Okay? So then you say, but what about the feather, right? I mean, and this is the kind of thing in the history of science that's very important to understand. When you start theorizing, you start with phenomena. And you make a choice among the phenomena because different phenomena will be suggestive in different ways. This phenomenon, I'm dropping them again, and again, the feather just floats down, absolutely suggests that the heavier object falls faster. The cannonball looks like it's going the other way. While the cannonball and the musket ball, they're falling pretty much the same. So how do we, where do you start? Which phenomena do you begin with? Which phenomena are simpler and which are more complicated? You want to get to the simple ones because the complicated ones are complicated. Now, we all know both what the correct answer to this is and the answer that Galileo gave to explain this feather business, and that's that you're not accounting for air resistance, right? The reason they're falling not together is because of air resistance.